everyone so much for coming to Scaling Simple. My name is Silvia Zeamer. I'm based in Boston, Massachusetts. These are some pictures from my life, which you're welcome to ask me about after. And I work at a cool little startup called Tolemi. We work with municipal governments, and I'm a software engineer, mainly working in Elixir and Postgres and a lot of little bits of other things. Also, this is our team. I may be the only human member per our Slack profile pictures, and we all work on our internal ETL tool, which is what I'm going to tell you about in this talk. And all these people are our kind of direct clients. They're data engineers who use the ETL system to build data pipelines, and we're all working together to support our external governments, which are cities, customers I meant, which are cities, counties, and states across the United States. So this diagram shows all of the data processing that we are running on a daily basis to support the city of Boston, Massachusetts, which is one of our customers, in addition to where they're based. So the green nodes in this are extract steps, which are connecting to external data sources owned by Boston or by public data portals. The orange nodes are transform steps, where we're usually matching that data to a property that is in the city, or we're doing some other processing. And then the blue nodes are load steps, which are publishing cleaned data back to Boston so that they can use it through this interface. So this is one of the things it's all powering. And basically, this is a map where every single property that exists in Boston is all plotted along with all of the information that we know about it. And it lets our clients filter by all of that. So we have about 130 customers as of today. And they have anywhere from like 100,000 to a few million properties. And so each of those steps you saw earlier, we are going to be like processing every single property, usually in each one of those. So quick timeline of sort of our ETL tool and the situation. So we adopted Elixir in 2018, about 4 years after Elixir 1.0 came out. And then it was previously written in Groovy, which is kind of in the Java ecosystem, and it has a lot of support for different data formats and parsing. But when we got to kind of needing to run like a lot of jobs concurrently, which this workload necessitates, our founding engineer was also in the Ruby ecosystem, and we ended up moving over to Elixir. I pointed out the date of Oban releasing. It was well after we started this code base, because a lot of what I'm going to tell you about is our sort of internally written jobs processing system, and we probably would have used Oban if it had existed. I joined in summer 2022, and I've been working really hard to make our data pipelines more complicated and difficult to run. So this acceleration of number of jobs processed is because there are a lot of like cool pieces of information that we are inferring by combining information for specific cities. And we took a lot of that and like standardized it and then deployed it to all of our customers, which really enriches what they get from us. And it also drastically increases how much we have to process. So super high level, we are pulling all of these different kinds of data from all of our cities. Angel, which is what we nickname our ETL, is processing it. It's loading it into a Postgres database, and that serves our customer-facing applications. And going into that in a little bit more detail, so what happens, usually we have pullers, which are pulling from one of those external systems. They're triggered to run on some basis, usually daily, sometimes weekly. And when they finish running, they then trigger everything that's downstream from them, and they trigger everything that's downstream from them, and so on and so on. And when that happens, when we run something, we are adding a record to a table of jobs, and we are setting its status to in queued. And we have a worker pool. The job record points back to whatever pipeline step in queued it. We have a pool of workers that pick up jobs and run whatever code the pipeline step might contain. And when they're done, they set the job status to finished. and they write any meta from that job to the job record as well. So like if there was an error or something broke, then they would write the error and the stack trace. And they remain there forever, which is nice if someone like me wants to make a graph like the one I showed before. So I'm going to go through a couple of sort of challenges that we face and how we have addressed them. So first off, how do we handle the wonderful diversity of ways we have to pull data into the system? So we pull from a huge number of different data sources and data formats. We are pulling from APIs, obviously. We are doing some web scraping. Some of our customers are sending files to us over FTP. There are some things that we are getting because somebody is handwriting an Excel file somewhere in a municipal office and emailing it to us, and we have to load that in. So you can imagine a world where Angel has a different pull function designed for each one of these formats that it's decoding, and it would just be pretty complicated. And happily, we do not live in that world. So all of our pullers are configured by our data engineers, and that configuration lives in the database. Some of them are code, some of them have a runner with some configuration. But however they are set up and whatever they might be, and there's a lot of different types. We have them in Python, in Groovy. We have some that are Elixir, and you just have to set what URL they pull from. They all produce the same format, CSV, a CSV file, and the schema of that CSV file. And so we don't have to deal in Angel with any of the parsing. We are just loading whatever that puller gives us back. And this is a quick look at what the interface looks like for data engineers. So basically for every little single city, we are pulling from EsriArcGIS. For spatial data, that's the most common source. So this is a farm, and there's a built-in Elixir puller. And a lot of our pullers are like this. They're just some code that is stored in the database, and we run it. But whatever the format, it's all creating CSV files. And so what that enables for us is this, which is really nice. Once we get the CSV file and the schema back from the puller, Angel just uses Ecto to connect to the database, and it streams that file into a copy command to load the data. So Postgres's copy is really well optimized, and so this is just offloading all of that work to bring in the data efficiently onto Postgres, and it works really well. And this is a theme. We like to offload things to Postgres. So how do we deal with how many jobs you're running all of the time? This is 1,000 jobs an hour. Many of them run near instantly, but a lot of them take a while. So we need to be doing a lot of concurrent processing. So this is, I'll sort of show you what our workers actually look like. Handling all that concurrency is, of course, where the beam, and OTP comes really in clutch. It gives us concurrency, it gives us process isolation, and it gives us cache recovery without having to build them ourselves. So walking through the definition of what our worker does, it reports to the gen server. We've picked up a job, we've got this one. It wakes another idle worker, which is going to check for any jobs it can do, and if it finds one, it's going to do the same thing. So that hydrates our worker pool really quickly. It runs the job, and then once it's done, it reports back to the gen server and asks for the next job. So this could be a lot of complex code in another language, but it can be this simple because gen server gives us that concurrency. Coordination. What happens if we try to enqueue a job that's already enqueued or running? Nothing happens. We've also dropped responsibility for this onto Postgres. So our insert command that we run to add a job to the queue checks for any jobs that are started or enqueued with the same pipeline step ID, which is our unique identifier for any one of these steps in a pipeline, and if we try to enqueue a job that's already enqueued or running, we just don't do anything. So we don't have to do any application level locking. We are just using that partial unique index. Oh my gosh, we have 2,000 jobs enqueued. How are we going to pick the next one to run? I imagine them like all of these baby owls demanding to be fed simultaneously. So we are also letting the database deal with this. We have an index on jobs. whether it's triggered by a user ID, whether it was scheduled to run at a specific time, and it's our ID, the ID of the job, which is auto-incremented. So ascending that way, you're going to get the oldest one first. And when a worker goes to get its next job, we prioritize ones that were run by a person first rather than on a schedule, then ones that were scheduled to run at a particular time, and then the oldest ones. So when we are actually going to retrieve a job, first we filter to ones that are in queued, and that hits the partial index we had earlier. So we have millions and millions of rows in the jobs table, like 30 million when I checked this morning. But this is fast because of that index, which is really nice. Then we look for jobs that don't have any blockers. So pipeline steps insert into a job blocks table anytime it enqueues a job that depends on jobs that haven't finished yet. And then in case we somehow enqueued the same job twice, we avoid running it. And we are ordering by our index. So stuff is always breaking in this system because we have some pretty brittle integrations like the aforementioned email situation. Schemas change, what URL something is served at change. So what do we do if a job crashes? This code is from the Gen server that manages our worker pool. Each worker is a beam processed. It's monitored via process.monitor, and when one dies, the Gen server gets a down message, and it basically just spins up a replacement job. And if the worker was processing something, when it died, it goes and finds the job it was processing, and it labels it as finished and failed. So this makes our system at most once per scheduled run. We don't auto-retry on crash, but our jobs are idempotent by design. So when they run, they create a table and they swap it out with the previously existing table at the end. So we could move to at least once pretty trivially. We are relying on the daily scheduling for retries. Oops, sorry. So the consequence of a break like this is usually just that the data that whatever it is pushing in is going to be like a day out of date. So for things that we really care about being super up to date, we have alerts that will ping us in Slack, and we'll go and jump on those and fix the specific issue. But in the meantime, our system is going to keep running, and that's really important because we don't want like a huge queue to build up. It would be overwhelming to get through and process. And then also, if something breaks, every single place that we are touching the database from these pipelines, it's wrapped in an ecto multi with a transaction. So if the query that we are running, most of our transformers are SQL queries, although some are not. If it breaks somehow, then we are just going to roll back, and it's going to be like we never touched anything. And then also, if something is wildly wrong and we have a demo in 10 minutes and it really needs to work right now, our eng team has the capability to SSH into the production server and hot deploy modules or run code, which is a really nice freebie that we get from Beam when something is urgently broken. I'm happy to say we have not had to use this as much over the last 18 months. It's something we try not to have to do and go through our deploy pipeline instead. And we've also been experimenting with defining live books with like sort of pre-written sets of commands for sort of common issues that we have run into. So I want to talk about pain points that we have a little bit. So first, our database is a pretty big bottleneck right now. Our job queue, our ETL pipelines, and our user-facing applications all hit the same couple of Postgres instances, and we are approaching the point where we kind of need to get more sophisticated with that. We are looking at DuckDB for moving some of the huge data sets that we are processing. We have some like national level data sets that are really heavy to be running through on a regular basis. Most of our jobs with regards to end-to-run jobs are scheduled overnight around the same time. So we get these huge but predictable spikes where like thousands of pipelines are kicking off at the same time because they'll be like on the hour and they're manually scheduled then. So we would like to smooth that out and spread out job scheduling or maybe offload the spiky parts to something like ephemeral compute. We are thinking about Flame maybe for spinning up on-demand Elixir runners. We have some observability gaps. When a job fails, we store the error on the job record, but sometimes like before that error came up, there'll have been logs that like went into our telemetry that would be useful for diagnosing what went wrong, and we are not associating that with the job in any way. So you kind of have to just go and look like when did the error happen, and then go in our entire logs and search for things that might be relevant. And we have some UI loading issues. There's a pretty big React front end on this system. We've had some bugginess with having things update. We looked at writing parts of it in LiveView a while ago and using portals embedded in the React app, but that ended up being kind of brittle. We would really love to somehow combine those, and hopefully I'll learn more at this conference about possibilities. We are planning to migrate our jobs to Oban in like the next year or so, and a bunch of this is going to get better when we do that. It does a telemetry event for each lifecycle transition. There's Oban Web. We start doing automatic retries, and it has orphan recovery, but we'll have to do some notable restructuring to get there. And then some takeaways, general advice that I have learned from this. Keep each layer thin. This has been said a lot everywhere, but I think it's really worthwhile to be able to like have a clearly defined thing that each module or function is doing that you can like understand, and then go down a level of abstraction and connect it to that. Keep worker simple, like this squirrel has just one job, to eat an acorn. There's a lot of built-in complexity in a worker pool. It's really nice for those to just kind of be self-contained. They're just running jobs. Oops. Oh, you didn't see the squirrel. I have some bugginess in my slides also. The database is really, it can do so much for you. I used to think of databases kind of just as a place to put data and retrieve it, and it actually has a lot of power to form how your application works, both in like the structure of the database, like our centering all of our information around assets lets us like really easily access a bunch of insights that our customers who are thinking in terms of like permits and code violations and assessments, all as separate things, just can't see. And also how you index your database. Use the Index Luke is a really cool online book that I recommend to everyone. Can speed things up a ton. The stream to copy pattern is doing a lot for us. Know it's important to you. Oh no, my cat is cut off. This is my cat. He's very important to me. There's always going to be things that aren't running perfectly, so think about what failures are acceptable and what you really need to nail and what are the consequences of failures. So like we've set pipelines, alerts for certain pipelines that we really need to be succeeding every single time. But most of our pipelines, it's like it's not the end of the world if they are out of date for a few days, and we kind of accept that that is going to happen. And build the simplest thing you can and know when to replace it. When you're starting a packet project that's kind of going to get off the ground, you're trying to figure out like what's the important new functionality this provides, and not necessarily like needing to implement it in like the most advanced possible way as you're going through some of those cycles of rebuilding early on. But also, be willing to go out and use the cool solutions that exist out there. We are transitioning to Oban hopefully soon. And also, I've been focused on the technical points in this talk, but I wanted to shout out my team. This is some of us in Barcelona meeting up this winter. We have a really nice work culture. We promote from within. We really encourage people to like go and adopt a problem and try to like fix it if they see something that's going wrong. And I think that's really foundational to having a good system and being able to do all of this work. And that's it. Thank you so much for coming. This was my first talk.